Hi everyone, and myself A.T. Naveen Prasad, Assistant Professor, Department of Mechanical Engineering, Vellore College of Engineering Technology, Erode. Today I'm going to present I'm going to present on introduction to refrigeration, like small introduction. So I welcome you all for this session. So first, definition and principle of refrigeration. So refrigeration is a process of removing heat from an enclosed space and maintaining it a temperature below the surrounding temperature. So it works on the second law of thermodynamics, which states that heat cannot flow from a lower temperature region to a higher temperature region without help of any external agencies. So heat can move from higher temperature region to lower temperature region without any external agency, but heat cannot flow from a body at a lower temperature to lower temperature region to higher temperature region without any external aid. So for this purpose, we are going to use either refrigeration or air conditioning system. So in refrigeration, heat will be continuously removed from the system at a lowest temperature, and at the same time, heat will be rejected to the surroundings at higher temperatures. So this is done only by using an external source, by using either compressor or a pump. So this is the layout of the refrigeration system. So later we can discuss about this. This is compressor, and the refrigerant from the compressor will be uh, passed through the condenser. So next the filter, capillary tube, and the evaporator, and the refrigerant will again back to the compressor. So later on, we can discuss about each and every component and the working principle. So the working fluid changes from the phase to phase, that is vapor phase to liquid phase after the heat rejection. So and also when heat is absorbed by the refrigerant, that means the fluid, uh, the phase will be changes from liquid to vapor after heat absorption. So the change of phase of the working fluid from liquid phase to vapor phase results in the cooling effect. So a machine which produces the effect of cold is known as refrigerator. So, and this process is called known as refrigeration. So in this, we will use a fluid called refrigerant. So that substance which is used to remove the heat is known as the refrigerant. So the most commonly used refrigerant are ferron, ammonia, carbon dioxide, sulfur oxide, hydrocarbon, ethylene, ethane, air, and water. So the refrigerant use must be eco-friendly, and it should not affect the environment and the living things. So these are the parts or components of refrigerator, which produces the cooling effect. So the refrigerator must consist of these parts, such as the evaporator, condenser, circulating system, and expansion device. So first of all, the compressor will be filled with the refrigerant. So when power is on, the refrigerant is compressed and pushes to the condenser with high pressure and temperature. Later, the condenser will remove the heat, and the pressure will be in the same state, of a high state from a compressor. Then the refrigerant will be expanded through expansion device, and later it will reaches to the evaporator. So from the compressor, the refrigerant will be in the refrigerant will be in vapor phase after reaching the condenser, and coming out of the condenser, it will be changes the state to liquid state, and from the expansion device also the refrigerant completely turns into the liquid state, and later have reaching the evaporator, the heat, the source to the heat to be removed from the evaporator will be absorbed by the refrigerator. So from the refrigerant, so the refrigerant again changes the state to liquid to vapor phase. So it is the evaporator is the heart of the refrigerator, where the liquid refrigerant is evaporated by the absorption of heat from the refrigerator cabinet, in which the substance have to be cooled or kept. It is known as the cooling coil or freezer. So it is nothing but the fridge, in which we will keep our substance like water or fruits, vegetables, in which we will keep inside the fridge is called the evaporator. So next compressor is a compressor or pump which circulates the refrigerant to undergo the refrigeration cycle. It mainly it helps to increase the pressure of the refrigerant and hence the temperature and also the temperature of the refrigerant. Condenser is a device in which the heat is to be removed from the refrigerant, is rejected at high temperature to the atmospheric air. So expansion device or valve which reduces the pressure and the temperature of the liquid refrigerant before it passes to the evaporator. So it automatically when coming out of the expansion valve, the refrigerant is completely cooled before it enters into the evaporator. So refrigeration effect. So refrigeration effect is nothing but it is the rate at which the heat is extracted by the refrigerator from the refrigerated space. Next thing is the ton of refrigeration. So ton of refrigeration is the capacity of the refrigeration system. It is considered as unit of refrigeration. A ton of refrigeration is defined as the quantity of heat absorbed in order to form 1 ton of ice in 24 hours from water at 0 degrees Celsius. In SI unit, the ton of refrigeration is given by 210 kilojoule per minute, and it is nothing but 3.5 kilowatt. So ice making capacity. So ice making capacity is the ability of the refrigeration system to make ice, or it is the capacity of the refrigeration system to remove heat from water to make ice. Coefficient of performance is denoted by the symbols denoted by shortly COP. The performance of an refrigeration is expressed by a factor known as COP, and it is defined as the ratio of heat absorbed in a system to the work supplied. So COP is equal to heat Q divided by the work supplied W. So relative coefficient of performance, the ratio of actual coefficient of performance to the theoretical coefficient of performance is known as the relative coefficient of performance. And it is the let us discuss about a few properties of put refrigerant. So as a put refrigerant, it should have very low boiling point and low freezing point, and it should have a high enthalpy of evaporation and low specific volume. And next thing, it should have a high latent heat of evaporation so that the minimum amount of refrigerant can accomplish the work. And it should have a low saturation pressure, good thermal conductivity, and it most important is non-toxic and non-inflammable, non-corrosive, and it should be economically for both initial cost and maintenance cost, and it should be chemically stable for temperature variations and neutral for lubricating the oil. So these are the some commonly used refrigerants and their properties. So ammonia, so it is mostly used in the refrigerant in vapor absorption system. It has a boiling point of 33.3 degrees Celsius, and it is highly inflammable, irritating and corrosive. But this refrigerant is used where it is toxic nature is not considerably seriously. Next thing is carbon dioxide. So it is non-toxic and non-flammable. Normal boiling point is minus 77.6 degrees Celsius. It also has low specific volume. The plant size is compact, and it is used in the ships where space consideration is more important. So next thing is sulfur dioxide and around 12, around 22, like that. So this is the vapor compression refrigeration system. So this is the compressor. So the first initially the compressor will compress the refrigerant. So the dry refrigerant vapor will be passed at high pressure to the condenser. So at condenser, the refrigerant is cooled to room temperature with high pressure only. Next, the refrigerant will be passed through the throttle valve, and the liquid refrigerant at low pressure and low temperature. The throttle valve is nothing but it's the expansion valve. The refrigerant gets expanded. So from the compressor, the dry refrigerant vapor will be comes out, and when it reaches and when it comes out of the condenser, the dry refrigerant vapor is converted into the liquid refrigerant at room temperature. After that, after it reaches the throttle valve, and while coming out of the throttle valve, the liquid refrigerant is expanded, so the pressure gets low. So again, it reaches to the evaporator unit. So this is the evaporator coil. This is the portion where we will keep our water or food or vegetables like that. So the heat from the kept material will be absorbed by the refrigerant inside the evaporator coil tubes. Again, the refrigerant is get heated and converted to the phase, and the phase change will be occur. The refrigerant from the coming out from the evaporator is converted into the dry refrigerant vapor again. So the heat from the heat inside the evaporator coil will be absorbed by the refrigerant, and it again come back to the compressor. So this cycle is an cyclic process. This is a cyclic process. So these are the most common arrangements of a vapor compression refrigeration system. Again, it comes under evaporator, compressor, condenser, and an expansion valve. So the liquid refrigerant in the evaporator, so it absorbs the heat from the system, that is the cabinet or refrigerated space, which is to be cooled and undergoes a change of phase from liquid to the vapor. So from in the evaporator, the refrigerant undergoes a phase change from liquid to the vapor refrigerant. So the vapor refrigerant at low temperature and pressure is again drawn back to the compressor, where it is again compressed and its temperature and pressure gets high. So the compressed vapor refrigeration then enters the condenser, where it is cooled, and the phase change will occurs from the phase change will occurs from vapor phase to liquid phase by removing the heat, and it is the removed heat will be passed to the atmosphere. So the high pressure liquid refrigerant again leaves the condenser and passes through the expansion valve. So in the expansion valve, the refrigerant is expanded. So its temperature and the pressure gets low, and which will less than that of the refrigerated space. So the low pressure, low temperature refrigerant again enters into the evaporator, where it absorbs the heat from the system and evaporates. So the low pressure, low temperature vapor is drawn into the compressor, and the cycle gets repeated. So it is a repeated cycle. So thus the heat is continuously removed by using a refrigerator, thereby keeping the system at required lower temperature. So this comes under the second law of thermodynamics. So with the aid of any external agency, the heat can be moved from lower temperature region to the higher temperature region. Thank you so much for listening me. Thank you. Thank you so much.